Well, ladies and gentlemen, hello again, welcome to another Reflected Reality Simulations video. My name is Graham, we're in X-Plane 10, and today we're taking a look at the FlyJSim 727 version 2. The FlyJSim 727 has been around for a few years now, but version 2 was released only last week. I've been playing with it for the past few days, and it's really quite an enjoyable aircraft to operate. It's got quite a number of systems simulated. 3 models of the 727 are supplied, and a few paints for it as well. I've also got the Delco Carousel Inertial Navigator on here, which we're going to be having a look at in this video as well. So if you've seen any of my videos on the IXEG 737, you'll know that I had a little bit of previous experience in the 737 sim, and the 737 is not too dissimilar to the aircraft type that operates on a day-to-day basis, just the same sort of generation of machine. The 727 is a little bit different. It's a much older design, and it's got a space for a flight engineer here with the systems panel. So a little bit more complicated to operate in FlyJSim, I guess, but it's certainly enjoyable, and you can be quite, you can do reasonably good flights with the aircraft. What makes it really helpful is these pilot notes, because you don't have to do a lot of study to learn how to operate this aircraft. The pilot notes are right here. So I've got full fuel load on the aircraft. We're at Shannon on the west coast of Ireland, and we're going to be heading down via the oceanic routes towards Tenerife North. Probably on the range limits of this aircraft, and in this day and age, as it's modelled, it wouldn't have the required navigation equipment, but in FlyJSim, doesn't really matter. Let's go through the pilot notes and get the thing started up. So it says battery on, that's up here. Click it on. APU or ground power on. Well, it's the APU I want, so it's down here. Put it on, and then start. Watch for the lights to flicker as it draws power out of the battery to start the APU. You can hear the APU starting up. Exhaust gas temps rising. We might be able to see the. Can we see the APU supply? Let's have a look. Okay, so we should be able to close the field now. Does it put any? No. Generator, close. There we go. So you can see the frequency and the voltage. That's fine. 110, 115 volts AC, and just about 400 cycles. Perfect. Stall warning check is the next thing. That's on the overhead panel. It's up here. So click it to test. The stick shaker in the background. Back to normal. Passenger signs as required. Well, we need to arm the exit lights. There we go. And put the signs on. It's a freighter we're flying, but it doesn't make any difference. We'll turn those on anyway. Window heat on. Window heat's up here. And radar, radio transponder. Well, I've got the squawk code set. Transponder can remain off for the time being. And the parking brake. Let's have a look. Parking brake is set down here, and we've got some brake pressure. Just a little bit on the low side, but that's fine. Okay, so APU is running. Next thing we'd normally do is start the engines, but what we need to do first of all is align the Inertial Navigator. So here's the Delco Carousel. I'll use the 2D window. I find it a little bit easier on the 2D window. Quite a finicky thing to set up. It's quite involved. It can actually load X-plane flight plans directly, but I'll do this. I'll just put the first 3 waypoints in, and you can see the process. So flick it to standby on the mode select unit. Make sure I'm looking at the position, and the first thing you've got to tell an Inertial Navigator is where it is in the world. So we do that simply by selecting position on the selector dial, and I'm going to tell it we are north 52 42.1, insert, and west 855.5, insert. In real life, the system we're doing some checks at the moment to see if it remembered where it was previous time and make sure I hadn't moved with the navigator off. All we've got to do is tell it to go to the align mode. We'll have a look on the status, and this is the performance index here. Once this 9 counts down to 5, the ready nav light will come on. We can flick it onto nav mode, and then we're good to go. What we mustn't do is move the aircraft while the navigator's aligning. What it's doing is sensing Earth's gravity based on how it's got a gyro platform that is fixed to a point in space, and it senses the gravitational force and adjusts the platform to keep the platform level, and that's why it needs to know the latitude so that it can align itself to true north and provide an accurate navigation solution. They're really fascinating devices, and modern FMCs have still got IRUs in them. It's just the user interface is a lot easier. In this thing, you're seeing exactly how to set it up, and you've essentially got a navigator without a database here. While we're waiting for it to align, we'll put in some waypoints as well. It's exactly the same as entering your current position. You put it to the waypoint mode, you choose the waypoint you want to enter on the thumb wheel. So the first waypoint, we'll use a point at the end of the standard departure routing out of here. It's north 52.22.5 and west 932.6. Insert. These are degrees, minutes and decimal minutes. So 52 degrees, 22.5 minutes, and 9 degrees west, 32.6 minutes. That's the first waypoint. Waypoint 2 is north 48.50.3 and west 12 degrees. Insert. And the third waypoint, north 45 degrees and west 14 degrees. Insert. And what we can do is check the distances between the waypoints. So from 0, the present position, to waypoint 1, the end of the departure track, or the departure routing, is 29 miles. If I click waypoint change and go from 1 to 2, it's 259 miles. And waypoint change from 2 to 3 is 503 miles. Because this system's very prone to entry error, without having a database, you're putting the lat lons in directly. You would check these with your printed flight plan just to make sure that you'd got everything correct, just to try and avoid as many errors as you can. So we just got to wait for that 9 to count down. It will start to move a little bit quicker in a few moments. I'll get rid of the INS just now, and what we can do is start the engines. So let's bring a little checklist back. So before we're ready to start, let's have a look at the systems panel and see what else we need to do. So we're going to need some bleed pressure from the APU. I'll open the bleeds here. That supplies bleed pressure, and we'll probably put some fuel pumps on as well. I'll put the forward pumps on all of the tanks. And I'll make sure that the crossfeed is set to engine to tank. So this tank supplies engine 1, this tank supplies 2, and this tank supplies 3, and there's no cross feed going on. One thing that seems to be required in the model, and I don't know if this is a real life thing or not, is you need to have the bleed on for the receiving engine. Normally the bleed is supplying bleed air from the engine, whereas the start valve would admit bleed air into the starter, but this one won't start. Or in fact, we can have a look at that. But what I'll do is I'll start engine number 3 first. So it's dead easy. I've got bleed pressure, more than 30 psi. We need to make sure the aircraft is set to start. So nav lights should always be on. I don't know why that's started from cold and dark with them off. Nav lights would always be on, so when electrical power is on the jet, you can see the nav lights. But to start the engines, I'll put the beacon on, and in case it's a ground movement radar, I'll put the transponder on, and everything else is set on the panel, I believe. Start switches are up here. We'll start number 3 first. So ground start. Check up the here. Start valves open up here. I'm looking for the N2 to come up to 20%. And when I get to 20%, put the fuel into the engine. You can see the EGT rise. The N1 will start to turn, and the engine should be self-sustaining in a few moments. It's a much smaller engine. It's a low bypass jet engine, so it spins up really quite quickly. You see the start valves closed already. So let's start number 1 now. I'll close number 3, number 1, ground start. N2 is turning. %, fuel goes in. And that's us. Start number 2. Ground. turning, fuel going in, watch the EGT rise, and start valves closed, so we can close that. On this panel, first of all, okay, so it's been left with the hydraulic engine pumps turned off. Again, those, certainly in my experience, you would never have those switched off, because as soon as the engine turns, you want hydraulic pressure to make sure the brake pressure is there. So we've now got hydraulic pressure from the pumps. We'll put the electric pumps on as well, and probably all the fuel pumps. Actually, let's put the generators on first of all before we increase the electrical load. So we'll put the field number 1 on, and generator on number 2 and number 3. I'm just doing this quite quickly now. I guess in real life the engineer would check that you've got the correct frequencies and voltages before putting them onto the bus. Right, so we should be able to shut down the APU now, and I'll put the other pumps on, the other fuel pumps that is, and hydraulic pumps are on. Make sure there's no lights on here. Go to flight mode for the pressurization system, and we'll turn the packs on. And engine 2 and the APU bleed come from a common source. I think on this aircraft you would only run the engine 1 and engine 3 bleed normally, so I'll turn those to close. Incidentally, that there is the reason why I started 3, then 1, then 2. I don't know if it actually makes any difference. I don't have the real operating manual for the 727, but it seems to make sense. It doesn't do any harm anyway. On the pressurization, I'm looking to 30,000 feet or flight level 300 today. So that looks like the engineer's bits and pieces done. On this panel here, on the flight position, I need to first and foremost set the trim. Just by clicking the hotspot there, it does it quite nicely. Set the flaps. I'm going to do flaps 15 departure. And the rudder trim's centralized. Now it's quite a basic aircraft. We'd have had the bugs set previously, but on this one it's just a case of clicking the V-speed card and it sets the bugs automatically for you. It's really quite useful, makes life a little bit quicker. So I'm going to do flap 15 departure, and flap 15 is selected on there. The auto flight systems, we'll not worry about those just now. The only one we're going to use is the flight director pitch control. I found that when you start it, it seems to not respond to the mouse input, but if I click it over to IS mode and then back to pitch, I can set a pitch target of 10 degrees now. Again, you'd probably do this when you're airborne. The other pilot would do it for you with you flying the aircraft, but in the sim we'll make life easier just by arming it ready to go. And we could probably have the flight director in heading mode as well for the runway heading. Okay. So I think we're more or less there. We've done the engineer stuff. We'll put the pitot heat on. The transponders are already on. What have we not done? Oh, I think that's okay. Let's just have a quick check through this before takeoff checks. Anti-ice, we've done. Pitot heat is on. Instruments are set. Flight controls in a minute. We'll do that. Stab trim set. Flaps. Galley power. Again, it's a freighter. Probably don't need that, but we'll turn them on just for something to click. No lights on the electrical panel. Yeah, I don't think there's anything on there. APU is off. Hydraulics we've done. Pressurization set. Flight modes and number 2 bleeds are closed, and the bugs are set. That's it. Okie dokie. So it's usually just the IR we're waiting for now. See the nav light is ready nav. So if I flick it from align to nav, you see that it is it's ready to go. 29 miles, and the status says accuracy 0. That's as good as it gets. This is in nav mode, and there's only a single IR here, or IRS, so mode 4 is how it will always display. Let's put it on distance time. Just one last check on the overheads. I've only had this aircraft for a few days, so I'm not 100% sure I've done everything that we should have done, but yeah, it looks okay. So, check on the outsides. Yep, we're only going to taxi over here, so it's quite a short taxi out, right, left, and stop before this holding point here. I'll put the taxi lights on, turn off lights on, Back into the view, release the parking brake. Just a little bit of power to get the aircraft moving. Again, you seem to need a little bit more power to taxi this aircraft than you would on the 737. I don't know if it's a function of those low bypass jets. Maybe there's not so much idle thrust on those. Notice the V-Speed card has got the clean-up schedule for the flaps as well. That's really quite useful. It saves you having to remember the speed schedule. Got a standby compass up here. We can flick that away if we're happy we won't need it. So there's no auto thrust on this aircraft. Reason being, it's got a flight engineer who, once the pilots have stood the thrust levers up, the flight engineer will take over on the thrust levers or the throttles. So what I'll do is I'll come to a halt at the line here, set the brake, and I'll get the aircraft ready for flight at the moment. I mean, normally you do a lot of this on the taxi out if you're two crew. I'll put the radar on now, and once it's woken up, I'll make sure the TCAS mode is selected as well. We can turn the taxi lights off, and we'll put the landing lights on. I'll put the strobes on. Beacon was already on, logo light should be on. Transponders to on and alt, and on this panel here we've got flight already, and I don't know about this auto pack trip. Normal sounds like it's maybe more likely to be the right answer. Packs are on, blades are set, pressurization set, temperature's good, and everything's looking good really. I think we're good to go. Get the brake off. Taxi out. It's a really nice looking model. I love the look of the 727 and things like the Trident as well, the Hawker Siddeley Trident. It just looks like all the power of the aircraft. It's a sleek looking design. High T-tail and rear mounted engines. It just looks like it's ready to go. 100 miles an hour when it's standing still, as they say. So departing off runway 24, the departure track is more or less runway heading, and we'll use the Inertial Navigator. It's an RNAV departure, the chart I've got at the moment. In real life, this machine you'd do a radio aid base nav, and then you'd use the Inertial Navigator much later on. So lined up on the runway, the pilot would stand the thrust levers up, and then the flight engineer would take over, advancing them to look for 2.15 EPR and maintain that to 80 knots, at which point they take the hand off the thrust levers or hold them in position. So there's 80 knots, the flight engineer would respond power set. On this version of the FlyJSim, the callouts are really quite quiet. I think they're going to improve that. Certainly in the version 1 it was a lot louder. So there's V1, rotate. Positive climb, gear up. I'm looking to fly that first white bug, which is V2 plus 10. Just keeping the wings level initially. So passing through 1,000 feet, I can lower the nose to start acceleration, reduce the power a little bit, and what I'll do just to cheat is click the autopilot in now, and it comes into heading mode, and I'll reduce the pitch attitude by about 5 degrees and let the aircraft accelerate. So once we pass 186, I'll clear up to flap 5. Once I'm within 10 knots of 186, that'll do. really quite heavy. It's taking a while to accelerate, and that's not unexpected, to be honest. There, so flat 5. Once we pass 210, so approaching 200, just above 200, I'll select flaps 2. Flap 2. And approaching 220, I'll select flap 0. There you go. Flap 0. Increase the pitch attitude a little bit. And we're still flying on the heading, so at this point I'll come down here and flick in the navigator. And it's going to fly and follow the nav track. Just watching the speed as well, 250 knots. When we get to 250, I'll click in IS hold, and the aircraft should pitch up to follow that. It's quite aggressive intercepting that nav track there, so you could refine it by using the heading. But keep life simple. First time off the ground with it. Another trap we've got here is it's not going to capture any altitude at the moment. I'm going all the way up to 30,000, but if you had a level off altitude, you need to come in here and click the alt select. It goes to arm on here, check it on the FMA and initiators here, you've got alt select, so it will stop at 30,000 or whatever you've got set on the alt selector here. So climb away clean, put the gear up and off, and I'll take the outboard lights off. Looking on the flight engineer panel, we are pressurizing, there's differential pressure building, and everything's looking good on the panel. I'll get rid of the V-speed card now, we're done with that. I don't know really about the power settings for the climb and cruise. It doesn't go into much detail in the manual. What I've been doing is on the V-speed card, you see you've got the nominal EPR and the nominal normal V1, N1, sorry. When you get to 80 knots, that's the value you should have on the window. Once we're beyond that, I've been reducing power to 95% N1 and keeping the EPR below 2.05. So as the airspeed increases, as the true airspeed increases, the EPR value will increase. So 95% N1 or 2.05, whichever one is most restrictive. That seems to work quite nicely. Let's have a look on the outside. Lovely clean lines on the 727, that sharply swept tail there. And the beautiful scenery on the west coast of Ireland as well. It's a lovely part of the world. You can see Shannon behind us and Lochfoyne. Let's have a look and see how our inertial system's getting on. So 11 miles to the turning point. 11 miles is also showing on here. That's perfect. And we'll be there in about 2 and a bit minutes. Once we get inside 2 minutes, the alert light will come on to say that there's a turn coming up. You can stop it from sequencing waypoints. On the real thing, you should be able to stop it from sequencing waypoints by flicking the switch to manual here. It's not implemented in this version of the carousel. So there's the alert light on, but it's happily doing what it's supposed to do. Approaching flight level 100, I'll take the landing lights off. Engineer over here would be verifying the pressurization's working. Everything else is looking as it should. Yeah, everything looks fine. So once we're through flight level 100, we'll increase the speed, looking for about 280 knots climb initially. Let's have a look at this. So another minute till the turn. Let's have a look at the other screens that we've got here, the other information. So heading, that's the true heading on the aircraft. Drift angle, well, if you've got any wind, that would show you the drift there. On this one, cross track, so 0.1 of a nautical mile to the right of track. That's what drives the CDI bar down here. And 0 degrees left or right track error. So we're spot on the track we want. Position is the current position. Waypoint is the just shows the position of the waypoint you have selected. Distance time is the time to the current waypoint, so from 0 to 1. Wind is whatever it's measured at the moment. I've got nil wind selected, and this is the navigation performance indicator here. So that's in nav mode 4. We've only got a single IRS units here, INS, so it's always going to say 4, and this is the accuracy. It starts at 0, 0 is good, all the way up to, I think it's 9, 9 is bad. So let's have a look at our cross track and the track error. Just 1 mile from the turn. When it turns, you'll see the waypoint sequence from 1 to 2. There we go. And it says I'm 23 degrees right of track, so it banks to the left, comes round, and we intercept the track. Exactly as it should. I spent quite a bit of time a number of years ago flying David Maltby's VC-10 in FlyJSim 2004, and there's a fantastic Delco Carousel implementation for FlyJSim 2004 that's actually free. I think it's actually has got better features than this paid for version of the carousel. For a start, you can operate 2 or 3 carousels simultaneously. It will cross mix between them. There's triple filtering, and you can also do DME updating between 2 separate units, as well as a 3rd unit to monitor. And it also seems a little bit more robust than this version. If you do some of the waypoint changes in here, it gets a little bit, it can get confused quite easily, so I'll try and keep it as simple as possible on the carousel here. The next waypoint is 225 miles away. It will take us 40 minutes to get there, and the nav accuracy is actually the performance is decreasing as that number increases. So 2 is still okay, but what we can do is update it from a local DME. I'll just align that heading bug first of all. So although it's a standalone system, it can read the distance from the DME. Because it's a 1970s piece of equipment, it doesn't have a navigation database, it doesn't know anything about DMEs, it doesn't know anything about waypoints. A modern FMS is exactly the same technology as this, except for the database behind it means it can automatically find DME stations and automatically update from DME stations without the pilots having to do anything. On this sim, we've got to do it manually, and we've got to do it using the keyboard as well, because you have to push 2 buttons at once. On the FlyJSim 2004 model, they did it just by having a right click and then select, whereas on this we've got to use a keyboard shortcut. It's not the end of the world. So what we'll do is I'll put it into waypoint, and normally the thumb wheel here will show you the navigation waypoints. But if I click this little hidden spot here till the K comes on, that puts it into keyboard mode. I'll hold down my Alt button and push 7 and 9 on the numeric keypad. This is now the DME updating mode. I need to now put in the coordinates for a local DME station. So Cork is not too far away. It's north 5150.4, insert, and west 829.7, insert. I also need to push the 3 and the 9 button together, so Alt 3 and 9. This is the elevation of the DME station. Cork is 500 feet above mean sea level. I'll put in 1,000, so north and 1, insert. The reason you need that is it's a slant range from the aircraft to the DME station. To make it as accurate as possible, you need to know the elevation of the DME station. When we're in this DME updating mode, we can only use the waypoint or the distance time selector. If we move it outside of those two, it will drop out of DME updating mode. So I select distance time, and it says it's 48 miles to the DME station. So Cork is tuned here, 114.6. You'd normally expect to see that here. This is the DME2 indicator, but this is the inertial systems distance. So what we'll do is just take a look over here. There's DME1 indicated here. It says 49, 49. That's pretty good, so I'm happy with that. I'll click waypoint change, 1, and insert. That 1 says stored DME station 1, start updating. Why did it not do that? Hang on just a second. Let's make sure it did do that. The problem with it in keyboard mode is you try and use the view keys, and it inadvertently does something else. So DME updating by waypoint change 1, and that's it. That should be it doing it. I'll take keyboard mode off now and actually just hide the window there. So through flight level 200. I'll have a look at what the engineer should be doing here. Keeping that N1 at 95, making sure the EPR doesn't go over 2.05. There's a note in the INS manual to maybe drop the aircraft into heading mode before you start updating the INS. That makes sense, but I'm quite happy with how it's doing it just now. So we'll just keep an eye on it. You'll note you can't change the course. It'll spin the numbers, but then comes back to whatever the INS has. It's getting a little bit dark as well. This model's got really nice lighting. We'll put the red dome light on. Make sure the panels are set appropriately. There's a panel backlight. It's got map lights up here. I think this is there we go. And you can move them around. And the same on the right side. There's a white dome light. And there's probably lights for the engineer panel as well. There we go. Fluorescent light for the panel. I'm very happy with the 727. It's a fantastic model. It's a good value upgrade if you've got version 1 already. It's $60. You get 3 models of the 727. Most of the systems work really well. This is the release version. I believe I've got like the first release here. There's 1 or 2 tiny little issues with it, but nothing that would affect your enjoyment of the sim. One of the other things the flight engineer should maybe be doing is looking at the fuel tank config as well, because he needs to do a little bit of work here. Looking at the 727, we've got probably about £11,000 in the 2 outer wing tanks and about £28,000 in the centre tank. What we want to do is to burn the centre tank down, leaving the wing fuel on here. Now at the moment the sim's doing that anyway. If we just look at the weight and balance, you'll see it's only burning fuel out the centre tank regardless of what my cross feed is set to. But to switch the switches correctly for that, we'd open the cross feeds, and that would allow fuel from the centre tank to feed into all of the engines. And usually in this kind of layout, the system's biased such that the centre tank, or the more capacious tank, if that's a word, the tank with most capacity I should say, that can provide a higher fuel pressure than the other tank. So we don't have to switch these boost pumps off. These pumps are more powerful. And that way it would actually burn down the centre tank, and once we get down to about £11,000, we'd close the cross feeds again. EPR's creeping up, so 2.05 being my limit, and also I'm climbing up to an indicated airspeed with the autopilot. Once it gets to about 0.72, I'll switch over to Mach instead of airspeed. Look at the INS. Let's go back on for the status here, and you'll see that it's down to 0. Again, that's really good navigational accuracy. So it's as up to date as it can be with the DME updating. On the real life installs, these Delco navigators, the last aircraft I think that used them in anger was Concorde. Concorde had 3 Delco navigators installed, and it used to fly the same routes back and forth every day, so the limitations of the system didn't really affect the operation of that aircraft. But for modern airspace, I don't believe it's got the required navigational accuracy or cross checks that you would need for the standard transatlantic routes these days. But it's really enjoyable in the sim. I do think the FS 2004 free version's got more, is a better simulation of the carousel. This would be closer to an emulation of how the device operates as opposed to simulating the features of it. But for something a little bit different from the FMC, it's pretty good. The 727, it can be fitted with the XFMC as well, just to make the aircraft a little bit more capable in the current airspace. There we go, leaving the southern coast of Ireland behind, heading out over the North Atlantic. At this point in real life, we'd be speaking to Shannon or Shanwick on the VHF, or maybe contact them on the HF to arrange our oceanic clearance. Most of the traffic on the North Atlantic is flying east-west from Europe to North America, but there's some routes that transit down from just south of Ireland, off Land's End, down to northern Spain and Portugal, all the way to Porto Santo in Madeira. There's 3 transit routes. You still need an oceanic clearance, and you still need the oceanic nav capability HF radio. So having a single long-range nav system would not be allowed on this route these days. You'd need to have 2 for the route that we're flying. But in the sim world, it doesn't really matter at all. So the last thing we've got to do in the climb is make sure that we transition from a indicated airspeed climb. As we get higher, obviously we want to fly a Mach climb instead. So what I'll do is flick the switch over to Mach hold and just make sure the bug's set to 0.71, 0.72. You see it reduces the rate ever so slightly, then it captures. To fly this machine on the autopilot, you've really got to think it through. It's not as intuitive to fly as the 737 model is on the autopilot, and the reason behind that is really quite simple. It's not an aircraft that was designed to be flown like a modern airliner. It's a stick and rudder kind of aircraft with the autopilot there as an assist, and it's really in the era where the other pilot is there to assist as much as possible in making the operation go smoothly. So having another pilot to make selections on the autopilot, the flight director, is essential almost for this aircraft. On the 737 we can program up enough of it that we can use joystick buttons to make single pilot ops a little bit easier. On this aircraft we have to just accept a few simplifications. So having it select in the heading mode with a flight director pitch command before we get airborne, probably not a good idea in real life, but we can do it in the sim just to make it easier. And again, it might be nice at some point in the future for this model to have a virtual flight engineer, just to carry out some of the mundane tasks that you'd have with an auto thrust on a modern aircraft. But just keeping the EPR set correctly now. You see I've gone to about 94% N1, just to keep it at 2.05. Again, entirely arbitrary values. But reason being, this aircraft's got a maintenance module in here somewhere. So you can see how long I've flown the aircraft for, any failures, and how long you've run the engine for. So if you have any mishandling of it, it will show you it shows up in here. You can turn it off if you don't like it, but it's pretty good. So there we go, that's the FlyJSim 727, and this is the 200 freighter. It comes with the 100 series and the 200 passenger variant as well. It's a lovely model, it flies really nicely, its radio navigation systems are pretty good. I'll maybe do another video with a more complicated departure. And it comes with a carousel. I think if you were buying the model version 2 at $60 plus another $10 for the carousel system, I think that's a little bit steep for the features the carousel provides. It is good, but the FlyJSim 2004 freeware version is more fully featured as a simulation. So it'd be better in my eyes if the carousel was included as part of the aircraft model, but I guess it's different designers have provided them. That being said, I'm really quite happy with the product. It's enjoyable to fly. So there'll be a few more videos with this aircraft, as well as there's a lot more content coming up for the IXEG 737-300. I did want to have a look at the PMDG DC-6 as well. If you've seen the news recently, there's been some big changes in Britain, certainly that's made the pound not worth as much as it used to be. The effect for me on that is the cost of the PMDG model has effectively increased by something in the region of 15%. So I'll be holding off for another few weeks on that, see if the market stabilises and makes it a better purchase. But for the moment, we've got the 727 and the 737 and all of the freeware aircraft as well. I hope you enjoyed watching this video. I hope you found it informative. As I said, it's a little bit different because I don't have the same background knowledge of this aircraft. But nonetheless, I'd be very happy to see your comments. Any questions, I'll try my very best to answer them. And if there's anything you'd like to see done with the 727, again, I'll try my best. Thanks very much for listening to me, and I look forward to speaking to you again soon. Thank you.